second graders. Today we are going to be learning about engineering. What are engineers? How do we think like engineers? Let's go ahead and get started. Alright, so I am sure we've all heard of engineers, but what is an engineer? So, an engineer is a person who designs and builds things to solve a problem. Design, in case you don't know what that word means, it means a plan to show the workings of an object before it is built or made. So, for example, if you're a software engineer, you might build apps that help people with problems. But before you put your app out to the world, you have to design it. You have to come up with a plan. There are also many other kinds of engineers. So, anything under the sun, there's probably an engineer for it. So engineers try to solve problems by designing solutions. How do we think like engineers? Let's check out this little clip here.
How do we get around from place to place without having to walk everywhere? How can we communicate with people who live far away? These were problems that people struggled with for a long time, until recently, before there were things like cars and phones and computers. And you know who solved those problems? Engineers. But do you know what an engineer is? The short answer is that an engineer is someone who wants to know how and why things work. Now, I want to know how and why things work, but does that make me an engineer? Not quite. Besides being naturally curious, an engineer is a person who designs and builds things, like machines or systems or structures that help solve a specific problem. There's more than just one type of engineer, too.
So, we learned a little bit more about what engineers are. We are learning how to think like engineers. So, the way that engineers think is called the engineering process. It's similar steps they follow to solve problems. There are several steps to this process, so let's dive into those a little bit more here. So the first step in the engineering process is we need to define the problem. So you may define the problem by asking questions such as, what is the problem? Who has the problem? And why is this problem important to solve? We don't solve problems for no reason. We need to have a reason behind it to help somebody or something along those lines. Our next step in the engineering process is to do research. So some ways you might conduct a research, and you'll learn this as you get older, is you may make a list of questions you have about the problem. You may also search the internet for the problem. You can usually find a lot of information on the internet. And you can learn more about the problem, like I said, either from searching the internet, or there are books that have a lot of good information in them as well. While you're doing your research, you may stumble across information about what somebody else has tried to solve the problem, and that may help you with your idea. And that leads me into my next step, which is develop a possible solution. So when we're developing a possible solution, you may write down different ways that problem can be solved. You may have one idea or many ideas to solve the problem. Okay? There's not one right answer necessarily. This is why your research is important. It's going to help you develop that solution. Our next step is designing a solution. This is usually where you get to draw. So as you can see from our picture on the right, this is the design for a house. So an architect, which is a type of engineer, that's somebody who designs homes or buildings, drew this, and this is a model of a house that they drew. So for example, you may draw a model of your solution. It doesn't need to look exactly like this, but it should show roughly what it looks like. I'm not asking you to be Picasso, but some sticks do. Hey, draw some stick people, that's what I do. It doesn't need to be super detailed, like I said. Our next step is to build a prototype. So a prototype is just a simple model that lets you test your design. So it can be as big as the real thing, or it can be a smaller version of the final solution. So if you look at our picture on the right, it looks like these kids must have been designing something to help them solve a problem. I see people up here. Looks like this girl is in a wheelchair. It looks like this may be some sort of library of a kind. And who knows, this could be something that might have to do with accessibility for people with wheelchairs being able to get into high places. That's just my guess. Our next step is, after we build our prototype, we need to test it. So this is where you test your prototype to see if it works how you want it to. Now, some questions you ask yourself as you're testing is you may ask, does it function the way I want it to? Does the bridge hold the weight of the cars? That's something that somebody who designs a bridge would ask. Does the app function how it should? That's someone who designs apps would ask, right? So I wanted to show you guys this picture over here. This is a fourth grader who they're testing how this custom prosthetic arm works for him. Now, usually if you get fitted for something like that, it takes multiple visits because the people who are engineering the prosthetic for you usually have to edit it a few times. They have to change it because we almost never find the right solution right away. And that's a really important thing to remember. So remember, like I said, most engineers' prototypes don't work how it is supposed to the first time. That's why our next step is so important, and that is evaluating solutions. So evaluate means to ask yourself whether or not it worked the way you wanted it to. So questions you may ask yourself when you're evaluating your solution that you had come up with is you may ask, what worked well? Why did it work? Why didn't it work? How could I make this better? So you need to think about all these questions, question every step. And you're probably going to come up with a great solution in the end if you do that. Let's watch this video on the engineering process.
I'm gonna take a wild guess and say you've probably used a phone, and I bet you've enjoyed the benefits of a little thing we call air conditioning. You know who made those things possible? Engineers. We were just talking about engineers in our last video, people who design and build things to solve problems, and there are lots of different kinds of engineers. No matter what type of engineer you want to be though, civil, mechanical, electrical, or a kind that doesn't even exist yet, there's a series of steps that all engineers follow when they're trying to solve a problem. This process is called, wait for it, the engineering process. Makes sense to me. So what sort of steps are included in the engineering process? And why do we need it? Let's go through it step by step and discover how awesome things are made. First thing you gotta do is just define the problem. I mean, before you can solve a problem, you have to figure out what it is, right? For example, back in the 1800s, an engineer named Alexander Graham Bell was trying to come up with a simpler, cheaper way for people to communicate. Back then, the best you could do was a telegraph, which was an old-fashioned system of sending messages over electrical wires. Bell identified his problem. Communicating with people who were far away was expensive and took a lot of time. So his invention, or solution to this problem, was something you may have heard of, the telephone. Nice. Now, once you've figured out what problem you want to tackle, you need to do your research. You can start by just making a list of questions you have and what information you need to start answering them. You can also look around and find what other things already exist that have tried to solve the same problem. Maybe they can be improved. A good example here is the man who helped us blow stuff up. The chemist and engineer Alfred Nobel invented the explosive known as dynamite. Not because he particularly enjoyed explosions, but because miners and other people who, well, needed to blow stuff up to do their jobs, needed an explosive that was safer to use. So before he started on that problem, Nobel did research to see what explosives already existed, which ones worked well, and which ones didn't. This takes us to step 3. Develop a solution. After your research is done, this is where you say exactly how you think you can solve the problem. And once you've thought of a good solution, you have to figure out how it'll actually work and what it will look like. So you have to design your solution. This is where you get to draw. Civil engineers always sketch out their ideas, like buildings and bridges and towers, to show what they'll look like when they're done. Gustave Eiffel designed the famous Eiffel Tower in France, and he definitely showed up on day one of construction knowing exactly what it was going to look like. On to step 5, build a prototype. A prototype is just a simple model that lets you test out your design. It can be as big as the real thing's going to be, or it can be a smaller version. You just need to have a prototype so you can test it. This may be the most important step in the whole process. Engineers need to test their design to see if it works like they want it to. So, say if your building's a big tower, does it stand up? Does it stay standing up? If you're designing something with moving parts, does it work the way you want? Now take it from me, my future engineers. You might have a great idea, a really terrific solution to a really big problem. But when you get to this step, your prototype probably won't work exactly the way you want. At least, not on the first try. Most engineers test their prototypes over and over and over again. That's why a lot of time and brain power goes into the very last step. Evaluating your solutions. Evaluating just means asking yourself whether things are working the way you want, or why they are, or aren't. I like to think of this step as question everything. This is when engineers review all of the facts and ask themselves questions, followed by even more questions. What worked well? Why did it work? Why didn't it work? How could it be made better? And most of the time, the answers to these questions are going to send you back several steps. Like, once you figured out why your prototype wasn't working, you'll have to design a new solution and then build it and then test it again. Sometimes engineers go through this process 4, 5, even 6 times or more. Take Willis Carrier, the inventor of modern air conditioning. He tested his prototypes for years before he figured out the design that worked the way he wanted and solved the problem he wanted to fix. Like all engineers, he failed a lot before he succeeded. And that's okay, because he learned something from every failure, which made his product even better in the end. And I, for one, am glad he kept going. So the engineering process is a series of steps that engineers, or anyone, should use when they're facing a challenge. The process is important because it allows engineers to experiment and also to fail. Both of these things give engineers a chance to go back and improve on their original idea, giving us something even better down the road. So the next time you fail at something, don't feel too bad. Think about the telephone, and the air conditioner, and the Eiffel Tower, and then try again.
Alright, so I really liked how at the end of the video, she reminded us, remember when we fail at engineering or something else, we can come back and make it something even better. And it might take several tries, a lot of trial and error. We all mess up, but it's important to remember to come back to it. Alright, I hope you guys enjoyed that information on the engineering process. I went ahead and I created some projects for you guys to check out. You should have some supplies for those. Make sure you read the instructions, and if you have issues reading it, ask out for help from a parent or an older sibling, or you can always reach out to me as well. I miss you guys, and I'll see you around. Bye.